Hello, AP Chemistry. It's Monday, October 26th, and I'm working on the strong acid, strong base titration problems for your Mastering Chemistry. I switched the problems around. The first one was a big multiple choice, so I see some people have already started it, but I ended up moving my multiple choice towards the end, so I'm just going to do the math problems first. All right, so I have a titration where I am titrating 36 milliliters of HBr with KOH. First thing I want to do in any of these problems is figure out what do I have going on here, which we're going to have strong acid, strong base, but eventually you're going to have these mixed up. So I look at this HBr. Okay, so this is a strong acid, KOH, that is a strong base. So as soon as these two things mix together, the first thing they're going to do is have a chemical reaction and react. So I'm going to have HBr plus KOH. I actually don't need it for this one, but that's okay. And the KBr goes together, that's a salt, plus the HOH, which we make water. 1 OH and 1 H means it's a 1-to-1 multimole ratio. Right away, when I look at my acids and bases, I can tell if it's not going to be 1-to-1. So for example, say I had H2SO4 plus KOH. Since there's 1 OH but 2 H's, I know that that's not going to work. I would need 2 of the OH's to react with 2 of the H's. So that would be a 1-to-2 ratio, but we're not doing that right now. So here's my equation, and in this problem right here, I want my initial pH. So I have not added any of the KOH yet. I have 0.175 molar HBr. I have 36 milliliters of it, and I haven't added this yet, the initial pH. So the initial pH for a strong acid, I just need negative log of the H plus concentration, and since this 100% ionizes, this concentration will be the same, so negative log of 0.175. And then put that in there using 3 decimal places. So you can do that to get your pH. The volume of base required to reach the equivalence point. So the equivalence point is when they react perfectly. So I want to figure out how many milliliters I need here. So I'm going to multiply that by that. And I have 6.3 millimoles of my strong acid, and it's a 1-to-1 mole ratio. So I'm going to need 6.3 millimoles of my strong base to react and cancel that out. And then I need to know how many milliliters to get with the 2.05. So I just did a reverse molarity equation. Molarity equals millimoles over milliliters. So I just added that onto there. So I'll need to divide the 6.3 by the 0.205 molarity, and that will give me how many milliliters I need in order to reach the equivalence point. Part C. Oh, and I didn't actually do like a BCA chart here because I only had this and was going there, so I just did a regular stoichiometry problem. When I have some of both of them, that's when I usually try to do kind of a BCA chart and figure it out. All right, pH when I have 11.1 milliliters of the base added. HBr plus KOH yields KBr plus HOH. Same thing, I'm going to always have the 6.3 millimoles of this guy, but the KOH, I've got a 0.205 molar and I've got 11.1 milliliters. So I multiply that, so this is 6.3 millimoles. I'm not going to rewrite it to save time, 0.205 times 11.1. So 2.2755 millimoles. I can look at this since it's a 1-to-1 mole ratio and figure out which one's going to be limiting in excess. So this is limiting right here. So this is going to be my X. So right here, I'm starting kind of my BCA chart. minus the 2.2755 minus the 2.2755. So we have none of that. Now I'm adding this, but this is a pH neutral salt, so I'm not going to really worry about it because that's not going to affect my pH. I'm just drawing up to the two columns there, the acid and the water. So I'm going to take my 6.3 minus that. So 4.0245 millimoles of excess H plus, because really that, and that, at this point, those are spectators. So I have excess of this. Remember though, to calculate pH, I need the negative log of the H plus concentration, and this is just my millimoles. So negative log of 4.0245 over how many milliliters do I have total? I have the 36 original plus the 11.1 that I've added. Sorry. So I'm going to divide that and then take the negative log of it, and that will be my pH. pH at the equivalence point. Well, this is a nice one. Since this is a strong acid, strong base titration, the pH at the equivalence point is going to be neutral, because at this point, I have no acid left. So I went back here to where it said how many milliliters. I have no acid and no base left. So the only thing I have at the equivalence point is going to be the salt plus HOH. Well, we know the pH of water is going to be 7 because we're going to always assume that it's at 25 degrees. And then we have to look at this salt and figure out, does it have acidic or basic properties? But this one is pH neutral because it is the conjugate of a strong acid and a strong base. So my pH here should be 7. And now the pH after adding 5 milliliters of base beyond the equivalence point. So this is beyond the equivalence point, 5 milliliters. So you have to know what the equivalence point was. Well, guess what? I didn't actually calculate that. So now I actually have to go back and calculate it. Let's see. So that would have been the 6.3 divided by 0.205. So you're going to want to go to part B and find your answer for part B. And this is my answer for part B. So the equivalence point is at 30.73 milliliters, but I'm going to have 5 milliliters past that. Since I understand what's going on, so now this is all of the base. Remember, at this point, I should have excess OH minus. We're going to have excess base here. So I have my HBr, and I'm going to be really careful when I transcribe these. I know that I got 6.3 millimoles of the acid because I start with that on every single one of them. The KOH is 0.205. Grab that right molarity. Yep. And then it's going to have 35.73 milliliters. I don't know if this randomized the numbers, so make sure that you go back and look at what you got for B. Oh, I just cleared that. 35.73 times 0.205. So I have 7.3247 millimoles here. And then I meant to bring that here. So I got 6.3 millimoles here. And it does make sense because it says I'm beyond the equivalence point. So that does look correct because I'm going to have none of my strong acid left. I'm going to subtract those. I'm going to have 1.025 millimoles of excess OH minus. My salt that I make is pH neutral, so I don't have to worry about that. And the water is neutral, so I don't have to worry about that. So this is going to be what determines what my pH is. And then I need molarity, not millimoles. This is OH minus, so I'm actually going to be calculating the POH first. I need to put molarity in there. So I'm going to have 1.025 millimoles over a total of, 35.73 milliliters plus how much of that acid was originally in there? 36 milliliters. So I'm going to add those together. 35.73 plus 36. 71.73. That divided by that, 1.025 divided by second answer. I hope that's right. And then, sorry, I don't have room. I get to go over here. Now when I take the negative log of that, that's my POH, 1.8449. Yeah, that all rounds up. So that's my POH, which that should make sense, right? I have excess OH minus. I shouldn't have such a low number. So I'm going to do 14 minus that. And then I get a pH at 12.16, 2 decimal places. There we go. Then we have another problem for you to do. Let me know if you're having a lot of difficulty of it. And then here are some questions. And you might want to do these after you did the rest of it, because you might be able to go back and look. Okay, so strong acid with a strong base. Initial, I only have strong acid. So how do I calculate the pH of it? Let's see. Strong acid's completely associated. That looks true. This all looks true. I know that weak acids do not completely dissociate, so I'm going to get rid of that. And then, what is this? That's not right. Ooh, this is sort of good. Oh, but strong acids partially, nope, that's not right. So read all the questions and try to eliminate how you calculate it. That one should be good. Oh, well, I guess they all have 7, so maybe it's not that bad. Do you have either an excess? Nope. Neither. They cancel each other out. That's how you get that one. And good luck. Let me know if you need any help.